Okay, I'm going to say some words, and I want you to tell me how you feel when you think about it. There's feelings associated with this, okay? So here we go. Fuzzy bunny. Hmm, okay, okay. How about this one? Ice cream cone. Mm-hmm. You get the feeling around that? Okay, let me throw one more at you. Subnetting. It's like which one of these is not like the other, right? Now I'm hoping at this point you've had a chance to go through this series and you've gone through subnetting. You're feeling like a fuzzy bunny, right? When you think about subnetting. But I will tell you, think about how you felt about it before you got into those nuggets and before you had an understanding of subnetting. Well, that's how a lot of people feel when I say the word access control list. Yes, that's 3 words. But when I say that, people go, ooh, because it's a big concept. There's a lot wrapped around it because it's used for a ton of things inside of the Cisco device, and there's some understanding that has to go with it. As in, if you've encountered access control lists before, you a lot of times will walk away. If you've encountered them in the real world or heard of them, seen them before, you walk away going, whoa, that was one of those weird, I didn't quite get that. Well, I'm hoping that by the time we're done here, you will feel the same about access control lists as you do about ice cream and fuzzy bunnies, and even hopefully subnetting. We're going to look at what these are, what they're used for, because they're not just for access. It's not just for turning a router into a firewall, although that's one thing you can do with them. We'll look at how to use them for security, how they are used, and then we'll look at types of access control lists. Let's start off with what they are. Definition. An access list is nothing more than a list, as the name implies, of permit and deny statements. So you can see right here on the screen, I've got permit 192.168.2.50. So immediately the question is, permitted to what? Well, we're not going to talk about that right now. That comes later. So, okay, what about deny 192.168.1.0, the whole subnet. Immediately our mind goes to denied from what? Well, we're not going to talk about that right now because that's not what an access list is. That's how it's applied. Now, I'm being very intentional with my words here because I really want you to catch what an access list. Let's look at one more. Permit TCP port 80 for this host. Okay. Do you see how it leaves you feeling incomplete, like you're only halfway there? You're like, okay, I get it. You're permitting that port. So what? To that server, from that server, what is it being permitted to do? Or like you feel I get what the statement says. It's like if somebody walked up to you, then they're kind of twitching and they're like, the brown cow jumped over the bridge. And you look and you're like, I have no context to what you're saying. You are crazy. Well, that's what an access list by itself is. It's crazy. It's just a list of permit and deny statements that do nothing until, okay, so I've given you, this is the technical definition, right? Here's what it is. Access lists are a matching mechanism. Right? It is a matching mechanism. So I'm trying to think of a good analogy. Let's do this. I'm making this on the fly, so we'll see if it works. So let's say that you had $1 million, and you're like, I'm going to give this money away. And so there's you put an ad in the paper, and 1,000 people come to you and say, I want your $1 million. And so you're like, okay, well, I can't just give it to all 1,000 of you. I have to filter you down. I have to kind of figure out criteria that I want to like as I'm thinking, where's this analogy going? Jeremy's going to teach you how to discriminate today. So I don't know how this is going to work out. So let's just say you're like, okay, everybody, all 1,000 people are in front of you. You're like, everybody that has a blue shirt, I'm sorry, you don't get the $1 million. Go home. Okay, everybody that makes this amount of money or more, you don't need my $1 million. You make enough. Go home. So you start filtering all these things until you finally get what you want, the things that are left. That was a weird analogy, but that's kind of what an access list is. So now put it in the perspective of your router. It doesn't have $1 million, but it does have a ton of traffic going in and out of it. And there's times where you want to match certain stuff to do something with it. You want to, for instance, match your voice over IP traffic. Why? Because you want to tell the router that's special. It's very special traffic that goes above everything else and has the priority. And to do that, we use an access list. Now, it's an access list that's applied in the way of quality of service. That's one way that we apply it. Or you might say, okay, I've got NAT set up. So up here is the internet. And I want to make sure that people can surf the internet, and I'm going to translate that. I'm going to apply NAT, network address translation, so that people are able to access the internet. Well, when you do NAT, you have to specify what traffic gets NATed. So that is done by an access list. It's when you see this, you're like, oh man, that totally feels like a firewall, right? It's like permit and deny and all. It feels like a firewall, and that is absolutely one way that you can use an access list, is like a firewall, to say this is allowed, this is blocked. But there is so many features in the Cisco router that depend on being able to identify traffic, and that's all an access list is. So that's why I left it very vague at the beginning. I'm like, well, here's a list of statements, and I said permit this, deny that, but I wouldn't go there. I wouldn't say, well, here's how it's applied, because how you apply it depends on what kind of feature you're looking to create. Now, I put making French toast in there. That's not literal. I'm just saying that, this list can go on and on and on. Any feature in the Cisco iOS, in the Cisco router, that requires you to identify a certain set of traffic is almost always going to be identified using an access list. Let me illustrate this by giving you an example of one of the more common ways that access lists are used, and that is for security. This is when people hear the term access list, immediately what their mind goes to, because they're like, oh, that sounds like a access security kind of function, and they can definitely be used for that. So first thing that we do is go into global configuration mode and create the list. Now, you actually identify the list by either a number or a name. We'll look at the config in the next nugget. So let's just say I create list number 50. And in that list, the first statement that I make is permit 10.1.5.1. Maybe that's that specific host that I'm really want to focus on. Now, second one is there's this guy who's been surfing the web all day. I'm done with him. I'm denying 192.168.1.53. Then I go down and I say, well, but you know what? The subnet 172.30.0.0/16. So that means essentially the first two octets of that subnet are what's looked at and permitted. So if I have some guy down here that's 172.30.1.52, he'll come in. The router says, okay, well, you are 172.30/16. That says the first two octets are relevant. So that's what I'm going to look at. So you are permitted. I don't really care that you have 1.52 on the end. That's fine. So that's kind of how the list is read. Now, let's look at the rules. The list is read from top to the bottom, and it will stop at the first match. Man, I should have thought of a better example. So let's say, okay, let's imagine this. Pretend that's not that. It is actually 172.30.1.5, right? There's that PC. So let's say that host is out here. He comes into the router. He says, hey, I'm 172.30.1.5. It says, okay, are you this person? Nope, I'm not. Because if you were, you would have been permitted. Are you this person? He goes, well, yes, I am. I'm sorry, you're denied. It does not go on to the next statement to find out, well, actually, you would have been permitted if you would have made it this far. It's like one of those movies, where somebody's reaching for the serum that would cure them from the poison, whatever they just drank, and then they die like a centimeter away. I hate those kind of movies. But they die just like a centimeter away. So it's like, well, if you would have just made it further, you would have, but I'm sorry, we had to deny you. Now, at the bottom of this access list is an implicit deny. You don't see it. It won't show up in the show commands or anything like that, but it's there. Meaning, as soon as you create an access list, you say, do this, do that, do this, do that. You create this list of statements, and the list goes on and on and on, however long you want it to be. There is no cap on how big these lists can be. You can make them 500 statements if you want to. But at the very end of it is an implicit deny. And what that means is if you have not been permitted somewhere in this list and you get to the end, you're going to be denied. Totally reverses the way that routers work as soon as you apply one of these. Routers, unlike firewalls, when you connect up, we've got fast Ethernet 0/0 connected to a whole bunch of computers over here, and they're all happy and they're trying to surf the internet. Routers by default are like, hey, everybody's welcome. Come on in. Come on. You're welcome to. No permission restrictions whatsoever. These guys can freely pass to the internet, and the internet can freely pass to him without an issue until you apply your first access list. It's like putting this little guard on the line. Here is our little guard standing here. If that's where I apply it, I don't know why his head's a cloud. That's his hat, I suppose. So the guard is sitting there, and he is protecting the router, from stuff coming to the internet, or from stuff going out to the internet. We don't know. We have to discuss the direction first of all. But that's what that guy is there to do. So as soon as I apply an access list, no more is there this free-for-all, everybody's allowed. We now have an implicit deny to deal with. More on that later. Access list is applied to an interface inbound or outbound. This is one of two of the most difficult things to get with access list. Perspective. How does this impact the router? So when I create access list 50, let me just give you a heads up. This is going to be created in global configuration mode. Global, as in, remember, things created in global impact the whole router. So from global configuration, I make this list, but it's not going to do anything until I go and assign it to an interface. This least as we're talking about security. So let's say I go into fast Ethernet 0/0. The command allows me to apply this. So I would say, I'll show you the command in the next nugget, but in plain English, apply access list 50, and I can either type in inbound or outbound. And that is one of the most confusing things. People so what does that mean? Like out from the internet, out from the router? Like these words, just the words themselves are like, what do you mean in or out? Like in from here or in from there or out from, what does that mean? When you're thinking, and let me I'll mention this when we get to the config again, but one of the biggest things that you can do to catch the direction, to figure this out, is be a router. I'm serious. Let's say we've got a router right here. It's got two interfaces, fast Ethernet 0/1 and fast Ethernet 0/0. I'm trying to figure out the direction. I know that I want to filter, right here's the internet, right? And I want to filter, all this internet traffic that's coming to me, and I have to decide what direction do I apply, in or out? What is it? Be the router. So if I'm the router, hold out your arms. I do this all the time. I know it's weird, but I hold out my arms to where I'm like, flying like a guy who's flying. So my arms are straight out from my side, and I look at my right arm and I say, you are fast Ethernet 0/0. I look at my left arm, which is held out to the side. In your arm, do this with me, please. Put your arms up. It's gonna feel weird. It's cool. It's all right. Nobody's watching. On the left arm, that's fast Ethernet 0/1. So this is I got to show you a picture. This is literally me with big old arms right now, standing out here, and me being the router. This is FA 0/0, this is 0/1, and I'm going to say, okay, if I apply it out on this interface, if I say access list 50, that means it's coming out of me, like out of my soul right here. Traffic is coming out. So if it's coming out of me, where is it coming from? Somewhere else. It probably came in my right arm and decided to go out my left arm, or maybe I have a WAN link in my head. It's coming in there, that's coming in there, but it's going out here because the routing table said it had to go out there to get to the internet. So again, me being the router, holding my arms out to my sides, I look and I go, okay, so it's going out that way. So if I were to say, okay, well, no, I don't want to filter stuff going to the internet. I want to filter it coming from the internet. Again, holding my arms out, I'm looking, I'm going, okay, then it must be coming in my right arm or left arm, depending on which perspective you have. It's coming in my right arm. So I'm applying it in fast Ethernet 0/0. Be a router. It's the best thing that you can be when you're trying to do this. Now, I don't stick my arms out all the way if I'm in a data set or something, because they're like, what are you doing? But I still use my fingers. I visually have to do it for myself. I point with my fingers. I go, okay, so I'm going out this direction, so it's going to be in. The reason you might say, okay, Jeremy, I get it. Stop now. Why are you emphasizing it? Because this is the fastest way to take down an entire network. What I just told you was that at the bottom of every single access list is an implicit deny, right? Deny everything. So if I am applying that in the wrong direction, if maybe I meant to, say permit this, deny that, permit this, so I'm saying these people are allowed to surf the internet, right? So if I said these people from my organization and all those happy people exist over here, they need to surf the internet. So I would say, okay, well, they are allowed to go out the internet connection. So this would be applied outbound. What if I mistakenly applied it inbound? Well, all of these are private IP addresses. They don't exist on the internet. So by applying this access list on the inbound, whoops, I did the wrong direction. By applying it inbound right there, none of these will come in from the internet. So essentially, in all internet traffic, it will say, nope, you're not this, nope, you're not this, nope, 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 denied. You pretty much took down the entire internet connection for the company by applying it the wrong direction. You may have had the greatest access list in the world, but just by that one command, you can sever your connection. And I can tell you, I've done it. I've done it more times than I am ashamed to tell you right now, because sometimes you just get going, you're like, apply. And here's the worst thing. The worst thing of it all is you're managing, let's say you're managing this router, and you happen to be sitting at home at 1 in the afternoon. That's the worst. Or maybe 1 in the morning, and you apply the access list in the wrong direction, and you sever your connection to the router. Your telnet session dies. Your SSH session dies because you just cut off your access to that router remotely. I've been there. I know what it feels like to be calling people at 2 in the morning saying, I'm sorry, I need to be let into the building. Yes, I know what time it is, but your company will be offline in the morning. Yes, I'm sorry. That's a sad day. All smiling aside, that is a sad day. So that's why I hugely emphasize how important the direction is. There are multiple types of access lists that you can create. However, boil it down to 2 that you will use on a regular, daily, almost daily basis, depending on what you do. They are standard access list and extended access list. A standard access list is used to match things based on only, we should put little, only the source address. Because of that, they have a lower processor utilization, and the effect that they have depends on how you apply them, and that goes for any access list. So let me expand a little bit on that. When I say a standard access list only matches on the source, let's again say that we're applying it in terms of security. I've got a router here that has a connection to 2 different PCs. Top PC is 10.1.1.50, bottom is 10.1.1.51. Okay, standard access lists can filter only on the source address. So I can say 10.1.1.50 is permitted. 10.1.1.51 is denied. So I can't, when you say, well, denied from what? Denied how? Well, again, it depends on where you apply it. So let me give a couple more connections. Let's say we've got a WAN link there. Maybe this connects to branch office, Texas, or whatever, so you've got a bigger network here. So let's say I want 10.1.1.50 to be permitted to access the internet, 10.1.1.51 to be denied from accessing the internet. So what I can do is apply that outbound right here. So as this guy tries to go out to access the internet, he will be filtering. It says, oh, you're allowed. Okay, great. You can go through. This guy, as he comes in, it'll say, oh, sorry, denied. You are not going to be able to access that. Now, let me I'm getting a little ahead of myself, but that's okay. Some of you might look at this and say, well, could I have applied this access list instead of outbound right here? Could I have applied it inbound right here? Yes. You can do almost anything in a Cisco router. However, it would not have the desired result because what would happen is this guy, as he tries to get into that interface, it would say you're permitted. So he's in. Now he can go wherever he wants to, out here, out here, out here. This guy, when he tries to get in, maybe I only wanted to filter him from internet access, right? But as soon as he tries to get in, what's the access list say? Deny. 10.1.1.51 is denied, so he can't even get to the branch office. He can't go out whatever that link goes to. Surely he can't go out to the internet, but we may have cut him off from too much stuff. So when I say effect depends on application, you can see just based on the one router that I have in this picture, where you apply it makes a difference. Extended access lists. Now, let me also mention one more thing. Standard access lists can be used, but are not often used for security. The reason why is they catch too much. Most people say, okay, well, I wanted to deny him if he goes there, but not there, and if he uses this port or things like that. Standard access lists are usually used for other applications, like quality of service. I could say this whole network gets the priority over that one, anywhere that they go. It's easy to match with a standard access list. I could say, for instance, this whole network is allowed to be NATed, network address translation. That's another common use of standard access list. So it can be used for security, but it's not too often. Extended is where the security is most often used. This one matches based on source and destination address, so IP address, as well as the protocol and source and destination port numbers. So let me define those. So source and destination IP address is who you are and where you're going. So what I can do is apply an extended here that says, I want to permit this guy, if he is accessing the website or DNS server or whatever, 4.2.2.2. Otherwise, I want to deny him. I can't do that with the standard access list. The standard just says, this is you, and you are permitted. I can't say from what or from where, whereas an extended I can. So source and destination IP address. Protocol. Protocol meaning the sub-protocols of TCP/IP. When you first learn TCP/IP, you quickly realize there's more to it than meets the eye. There's TCP, there's UDP, there's ICMP, which is used for things like pings and all that. TCP and UDP we've talked about. I think we even mentioned this one. There is ESP, which is used for VPNs. We get into things like OSPF. I mean, these are all protocols that exist inside of this TCP/IP protocol suite, and technically at layer 4 of the OSI model. We can match any one of those using extended access lists. So I can say, maybe I want to allow TCP port 80. We'll talk about port numbers in a little bit, but deny UDP port 80. I can separate those, but allow pings, which is echo requests from ICMP. So there's all kinds of things I can do with the protocol, and then source and destination port numbers. That's the actual, so I can say TCP. I want to allow all of TCP, or maybe I just want to do port 80, which is HTTP. That's what that port lines up to. Or maybe I want to only allow port 25, which is SMTP. That's email services. Now, this guy does cause higher processor utilization because he's examining more. So it's going to cost a little more on that side. And this one is where that fear of access list comes from. The syntax of it takes a little time to learn and get used to. So give yourself some grace when you're learning this. It may take you a couple times. Okay, it's one of those like subnetting. First time you see it, you're like, what? And then as you see it more and more, you're like, okay, I'm starting to piece this together. Last one is something called a reflexive access list. We may talk about this one. What this does is allow return traffic for internal requests. Here's what that means. Sometimes when people first think and learn about access lists, they go crazy. Whoa, what did I just do? There we go. They go a little bit crazy because they're like, okay, I want to come in here and I want to make sure that my network is secure. So I am going to deny everything from the internet because there's all kinds of mean people out here. We want to block them all. I keep them out of my network. Well, that's great, but what happens when your internal computer comes in and says, well, I want to get to Google? Or I want to get to Microsoft.com to do some research, or Cisco.com, and Cisco tries to send website information back to you. Well, they can't. So yes, it's kind of like perfect security. You would never have anybody be able to do anything, and now you are secure. That is true, but we have to allow some usability. So when you bring that up, you go, oh, well, is there a way that I can watch it somehow, and when the router sees something being requested, then I allow just what was requested to come back? The answer is yeah. That's exactly what a reflexive access list does. Some people call it TCP established access list. So that's, your router has eyes, and as traffic goes out, it's always watching and says, okay, I see what destination you're going to, what port you're going on, what sequence number you're using. So when that site, and only that site, only responding to the request that I saw, comes back, I will allow it to come through. But once we're done, once we tear down that connection and you close your browser or whatever, we killed the TCP session, now that website will be denied from ever coming in uninvited. So here we go again. You ready? Fuzzy bunny. I'm just kidding. So do access lists feel a little better? Probably not. Honestly, at this point, if I were you, you might say, okay, well, I kind of see what you're doing. I get the concept, but access lists are really learned by doing, and that's what I plan on using the next 2 nuggets to do, is go through access lists with, just like we did subnetting, example after example. Okay, you get it? Example again. Okay, get that? Okay, example again. So we just keep seeing it and seeing it until we are absolutely 100% sure we've got it. For now, I hope this has been informative for you, and I'd like to thank you for viewing.